Question of the day. Have you ever wished you could build robots? What if you could design and work with robots without ever having to write a single line of code? That's exactly what Microsoft's latest robotics research is all about. Welcome to PathFinder, where we share and break down the latest news and insights in the world of AI and future tech. In this edition of AI News, we're exploring how Microsoft's robotics team is using ChatGPT to make it possible for even non-technical users to work with robots using natural language instructions. Using ChatGPT, the researchers demonstrated its ability to solve a variety of robotic tasks, such as using a robot arm to arrange blocks in the shape of the Microsoft logo, using a drone to inspect a shelf in a lawnmower pattern, and finding and navigating to objects using a robot equipped with computer vision capabilities.
But aren't these things possible without ChatGPT? Sorry, Bella, I hope you don't mind if I join you on today's expedition. As someone who's always been fascinated by robotics, but never acquired the technical knowledge to work with them, Microsoft's latest research is quite exciting.
Happy to have you, Ron. And sure, they're possible without ChatGPT, but comparatively, the current robotics development process is slow, expensive, and inefficient. Current robotics pipelines require a highly specialized robotics engineer who sits inside the loop, continuously writing new task-specific code and specifications to correct the robot's behavior. With ChatGPT, a new robotics paradigm is unlocked in which the engineer is pulled out of the loop, and users, even non-technical ones, have the ability to sit on the loop, monitoring the robot's performance and generating feedback and behavior corrections via natural language prompts.
I see. But I'm still a little skeptical because I remember reading research done in recent years where there have been multiple attempts to incorporate language models into robotic systems. Although I agree that using large language models in robotics has many potential advantages in theory, most approaches have shown severe limitations. For example, they have a rigid scope or limited functionality, or they lack the ability to interact fluidly with users and adjust to user feedback. And one of the biggest challenges in applying language models to robotics is that robots need to have a deep understanding of real-world physics, environmental context, and the ability to perform physical actions. They need to be able to interpret and execute commands in ways that are physically possible and make sense in the real world. What's different with ChatGPT?
ChatGPT's ability to engage in conversational dialogue and retain deep context enables the creation of a generative robotics model, a system that uses a conversational language model like ChatGPT to generate code for robotics scenarios. This model allows users to engage in behavior correction in a more flexible and natural manner. Rather than finding and revising coding errors, which would require specialized coding knowledge, the user is able to iteratively provide a detailed prompt, run ChatGPT's output through a simulation, and then use dialogue to move the simulated output towards the desired result.
I see, but this still sounds like theory to me. How do we make practical use of ChatGPT for robotics applications?
That's where prompt design and engineering comes in. It's an art that requires a balance of trial and error and design principles. And through empirical science, Microsoft's robotics team constructed a guide for writing prompts for robotics tasks. Here's how it works. First, you define a set of high-level, descriptively named robot APIs, i.e., a function library, which maps to existing implementations on the robot platform. Using descriptive names helps ChatGPT reason about the behaviors of the APIs and understand what's being asked of it. Next, you write a text prompt for ChatGPT that describes the objective to be achieved and any constraints, such as the specific coding language to use or how ChatGPT should form its answers. More importantly, the text prompt should explicitly state which functions from the high-level library are available. This helps ChatGPT to create a logical sequence of actions based on those available functions and makes it easier to apply the same principles across different scenarios and platforms.
So rather than asking ChatGPT to generate code unique to each robot or API, its expansive knowledge base is leveraged to serve as a logical and creative problem-solving element. And low-level execution is then handled by the back-end library implementation.
Exactly. Once the prompt is submitted, you stay on the loop. evaluating ChatGPT's code output either through direct inspection or using a simulator. Using natural language, you then provide ChatGPT with feedback on the answer's quality and safety to progressively improve the result and ensure risk-free deployment. Finally, when you're satisfied with the solution, the code can be deployed onto the robot. It's a process that requires a delicate balance of creativity and precision, and the results are well worth it. In one example, the team gave ChatGPT access to functions that control a real drone. They noted that it served as an extremely intuitive interface between the non-technical user and the robot. ChatGPT asked clarification questions when the user's instructions were ambiguous and wrote complex code structures for the drone, such as a zigzag pattern to visually inspect shelves. It even figured out how to take a selfie.
Similar to Microsoft's goal of turning Bing AI into your co-pilot for the web, it sounds like they have a vision to create a co-pilot for robotics. And with ChatGPT, they've demonstrated a generative robotics model that can adapt to different form factors, the physical design and characteristics of a robot, and simulators, while allowing users to essentially talk to their robots and get them to achieve desired behavior.
As with any developing technology, there are limitations. Being a pre-trained language model, ChatGPT's responses are still limited by its training data and the quality of the prompt. Additionally, ChatGPT may not always generate code that is optimized for a specific platform or scenario, which could result in inefficiencies or suboptimal performance. Microsoft's robotics team emphasizes that the outputs from ChatGPT are not meant to be deployed directly on robots without careful analysis and thorough simulation trials. AI and robotics research is moving fast, and Microsoft's hope is to revolutionize the robotics industry by inspiring and enabling future research which fuses large language models and robotics, paving the way for the development of new, innovative robotic systems that we can interact with in a natural, intuitive manner. To this aim, Microsoft has released and is developing a number of tools and resources. PromptCraft is a collaborative open-source platform where anyone can share examples of prompting strategies for different robotics categories. Besides prompt design, they are also working on multiple robotics simulators and interfaces that will allow users to test their ChatGPT-generated algorithms. To start, they've released AirSim, a drone simulator with a ChatGPT interface. You can find these resources, including the research paper, in this video's description. That's it for this edition of AI News here on PathFinder. I hope you enjoyed this expedition into the vast world of AI. And remember, even if AI may potentially one day take our jobs, there's one thing it'll never take: your ability to smash that like button and hit subscribe. So make sure to do both now, because in return, we'll keep bringing you regular updates on AI news and insights. Thanks for watching, and I'll see you in the next one.